Hello everyone, this is Amritpal Singh. Welcome to the next video of R programming language series. In this video, I'll be talking about another package in R which is used for visualization. It's called PLOTLY. So first of all, we'll see that why we have to use PLOTLY or when to use the PLOTLY. What is the speciality about PLOTLY? So let's talk about it first. First of all, when to use PLOTLY, right? So first of all, if you require the graphs to be presented in a digital or online format, then you can go with the PLOTLY. Or if you want the users to interact with your graph, then again, the second reason why we have to go with the PLOTLY. You want more customizability. You want to customize your graph much more than the GGPLOT allows. We already have talked about GGPLOT in the previous video. So over there, if you want more customizability, which GGPLOT doesn't provide you, then you can go with the PLOTLY. If you want to render graphics in a higher resolution, then again, the PLOTLY is the best option because it make use of behind the scenes JavaScript to the render graphics in a higher resolution. So if you want to collaborate with the others across the languages like Python, Bash, Node, then again, it's the best option to go with that. At last, if you want to build some unusual chart types which is not available in the other packages like treemaps, sunburst, sankey, and many more, then again you can go with the PLOTLY. So there are numerous reasons available why we have to go with the PLOTLY as a package. So first of all, what are the features? Now, what is the speciality about PLOTLY? So first of all, it has got multiple complex set of features. The most common features are the tooltip hover info. I'll be showing you in a while while we do the demo of it. The zoom in, zoom out of the graphs, right? The users can export graphs as an image and many more other options available in that PLOTLY graphs. So let's see first like how we can start with the PLOTLY. First of all, we need to install the package called PLOTLY. Then only you can work with the PLOTLY graphs and all, right? So we have a function available, plot_ly function, which is initializing the graphing library, right? So let's see the very first example. In the first example, we'll be talking about the scatter plot, and I'll be using the empty cars as a inbuilt data or a input data for the first graph. So let's start with that. First of all, we are putting this empty car information into a df, and we are extracting the row names. We are putting the row names into the name right here. So you can see it here, row.names. We all are aware that empty cars consist of both column names and row names. So we are putting the row names into a name so that we can use it in my graph, right? First of all, let's create a simple little graph in the PLOTLY, the regular scatter plot, in which the data will be coming from the empty cars, right? The x-axis will be a cylinder column and the y-axis will be displacement column. In this case, we have to use the prefix tilde sign. It's a part of the syntax. That's why you can see it here, tilde sign available. So let's do the very first little graph here. I'm copy here and pasting in the R console, which has already been opened here. Let's see. So here I put the things here. Let's see what information we'll be getting here. You can see here automatically when I press enter, the graph got displayed in the browser, and in the browser you can see multiple options available. If I hover the mouse over the points, I can see the points, right? It's a dynamic kind of content, and again we got multiple options. Download the plot as PNG, zooming in, zooming out, right? Selecting the box, and many more options, right? You can see it here, right? That's a point that we are getting. This is the advantage we get with the PLOTLY, right? This is the first little graph we got generated, the regular this one, scatter one, in which all the things are being shown, and if you go hover the mouse, you can see the values been changing accordingly. Next example in which everything remains same, but we just now I want to add the color. Meaning is like, because in this empty cars data frame, we are having this cylinder column available, which consists of multiple type of cylinders. What I want this, that maybe a 2-cylinder car will be represented with a different color, 4-cylinder car will be different color, and the 6-cylinder car will be different color. For that, I'm converting the cylinder column into a factor. Right, we all have seen the factor, the levels concept in the factors topic, which I've already have uploaded in my playlist of R. Let's see it now. What will the change if I go with this particular syntax? Everything remains same, but we are just putting the color equal to tilde factor CYL, means I'm converting the CYL column into a factor so that I can have a different colors for different cylinders. Let's see it here. If I press enter again, you can see earlier we were having everything in a blue color, but now, because of the fact I'm using a color here, you can see it here. The 4-cylinder car represented with this color, 6 represented with this orange color, and 8 with a different color, right? So we got different colors for different cylinders. right? So this is the another speciality about the plot ly. Another, moving further, now I want to add the names also. So you just remember that we already have put the name, the row dot names into a name column of the df. So I'll be using that name here so that I can see the names of the cars as well, right? Currently there's no cars names available in the graph, so let's now add little more information to make it more meaningful. So I'm going with that, in which you can see some changes now. If I can go, I'm hovering the mouse over the points, I'm also seeing the cars as well. In the previous graph there was no car names available, but now the car names are also coming in alongside, right? So we have went with the first little graph, which is a scatter one, with the help of the regular plot ly function. Now let's go with the second one, the histogram. Because plot ly have a very rich library of the graphs, right? So let's go with the histogram. First of all, I'm attaching iris so that later on if I have to call any of the column name of the iris data, I don't have to call iris $ that column name. So while you go with the attach function, it has been attached, so it means you can use the column names of that data independently, right? So here I want to draw the graph between the I want to draw the graph, the histogram, right, based upon the sepal length, right? So in this case, I'm putting, I'm using a layout function. Layout function meaning is, if you want to add this to the existing visualization, you want to specify the layout, means what will be the title, right? And what will be the on the x-axis, what will be on the y-axis. So this thing we want. Now let's go with that. We have a plot ly function in which x equal to sepal dot length, type equal to histogram, and in the layout section we are specifying that what should be the title, what should be the x-axis, what should be the y-axis, and in this case let's see how the graph turn out to be, right? So I'm putting it here, so press enter and you will see the histogram correspond to it, right? We have a sepal length versus count, and the title has been iris dataset sepal length. So it's all been decided with the syntax here, whatever we have used here, right? Done. So one thing more, guys, the x-axis and y-axis need to be specified in the list only. It's a part of the syntax as well. So maybe it's a single thing we have to specify in the list only. This is a part of the syntax. Moving further, how we can draw the bar chart in it. For that, the bar charts, what we are doing here, we are specifying two vectors here, beverage, vegetable, dairy, and we have the corresponding values 20, 14, 23. I want to draw the bar chart, so I'm specifying type equal to bar, color equal to orange. So this will be coming under the FIG. So FIG now using the DPLYR, this pipe operator, we are sending it to the layout so that the layout can be added to the existing graph, right? Now let's do it. First of all, let me load the library DPLYR, because I want to use this pipe operator because it is defined over there. So I'm going with the DPLYR. Okay, done. Now let's go with that. First of all, let's define the FIG, in which we are specifying that I will be having this values, right? It's been done. So now with the help of pipe operator, the output of FIG will be going to the layout, which will be deciding the title, x-axis and y-axis, and at last with the FIG will be printing the graph. Let's do it. Now here we'll be having the bar charts got printed with that. And if I press enter, you can see the bar chart got printed, in which we got the bars available correspond to beverage, dairy and vegetable, because I've already have specified these three things in my query already, that the beverage will be have a value 20, vegetable 14, dairy 23, and I've already have specified the color orange, and the title is sales by parts of supermarket. X-axis we got this parts, y-axis we got the number of sold product, right? This is called the bar chart in the plot ly. Moving further, next graph we got. In this case, it's also a bar chart, but now I want to compare the sales of my beverage, vegetable and dairy via 2 years. I want to compare my sales 2019 versus 2020. For that, the only thing which will be new in this case, first of all, we are converting, we're just making a data frame out of this. These are the three columns we can consider. With the help of data.frame, we have a 3 columns: parts, sales underscore 2019, sales underscore 2020. This is my DF, right? So on that DF, first of all, we'll be going with a regular plot ly function, in which we have x equal to parts, y equal to sales underscore 2019, type equal to bar. Is everything normal here, right? But what will be the new thing in this case? I'm using a function called add underscore trace. So what is add underscore trace is? So the add underscore trace is used to specify second argument of y-axis, meaning is I want to compare my 2019 sales with the 2020 sales. So I need to have a 2 bars. Okay, the means I want to see the beverage sales in 2019 versus 2020. So the two bars, consecutive two bars will be shown correspond to beverage, consecutive two bars will be shown consecutive to corresponding to vegetable, and consecutive two bars will be shown correspond to the dairy. This is a point, right? So only new thing is there. It is called add underscore trace, with the help of which we are also specifying the second argument of a y-axis, right? Now let's do it, right? First of all, let's create our data frame here. So this is my data frame, which will be created in the df. So df is my data frame. Done. So first of all, we are just specifying the single regular bar chart here, right? Done. So now on this bar chart, what we are doing, we are adding a second value of the second argument of the y-axis. So here I'm having this add underscore trace function. Let's add to it. So it means I'm adding an extra layer to my already available bar chart. At last, we are now sending this fig to the layout function so that I can add the title, x-axis and y-axis, and this is the point. In this case, we are specifying bar mode equal to group. Bar mode equal to group meaning is I want to have two consecutive bars correspond to beverage, vegetable and dairy, right? If you want the stack bar chart, we have to change this bar mode to the group, to the stack, right? Let's first add this one, then I'll show you the stack bar chart as well. Last point coming up here. Let's now draw the group bar chart with that. So if I press enter, you will be finding that I'm having this comparison available of the beverage 2019 versus 2020. Again for dairy 2019 versus 2020, and same for the vegetable as well. Now if you want to have a stack bar chart, only one change you have to make, rest all the code remains same. We need to have this as the stack. If I just changing it to the stack, I'm running this all again, okay, for you. Let's see if I can get the stack bar chart or not, right? Only one thing we have to change, the bar mode. Enter, and here I'll be getting the stack bar chart available, right? So only one thing we have to change, which is this one, bar mode. Okay, what kind of bar chart you require, right? Moving further, then we have a box plot available, although I've already have shown you the box plot in a separate video, but the plotly also also give you the option of drawing the box plot. Again, this box plot will be drawn on the this iris data set, right? So let's do it. In this case, we have a box plot available. In this case, plot underscore ly, y equal to sample underscore length, type equal to box. Earlier the type equal to bar, now it's been changed to box. Rest everything is same. Let's do it. So just we have to keep on changing the type here, the type of the graph, whether you want bar chart, you want histogram, you want the box plot, rest everything remains same. So I'm pressing enter, and you can see the box plot correspond with three species of the iris data set. One is Setosa, you can see the legends also, Setosa, versicolor and Virginica. And good part is, like, everything has been shown here. Just see this, we have a minimum value, we have this lower fence, we have this quarter 1 q1 quartile, the median, the quartile 3 and maximum 1, right? This is the point, and this is the speciality about this plot ly, which I'm not getting, we are not getting in other packages, right? Everything got displayed in a proper shape, right? Moving further, we have done with the box plot. Next is time series plot. So time series plot is a special type of plot in which we have a data in a consecutive fashion. It means we have a, like, best example of the time series mean, like, if you want to draw how the temperature is changing, right? It's a consecutive numbers, right? So this is called time series plot. And again, we cannot have the time series plot like drawn for any kind of data, right? For that we are specifying, we are specially using the air passengers, because if you go with the air passengers, let me show you one thing here. If you see the structure of air passenger, which is the inbuilt data set of R, let me show you. That's the reason we are going with that. It's a time series data, right? So it means not any data, not any data I can use it for this time series plot. Only the data which is of a type time series, which means the data which is in continuous fashion, it's keep on changing, right? This is the point. It's called time series. For that, I'm just drawing a scatter plot out of this, right? You can see it here, type equal to scatter, mode equal to lines, and here we are sending the layout, right? And we have a title available, plus we have a x-axis, y-axis. Now in this case, everything remains same, just the only change we are having is, like, the type is equal to scatter, but it will be a scatter plot, it will be a time series graph, right? Let's do it. I'm pressing enter, and you can see the this one time series graph, which is the continuous in fashion. There's no break available, it's in a continuous fashion. This is a point about the time series. So this is the point. That's why I've said that not any data set can be used for printing the time series. Because of the fact the air passengers has a structure of time series, that's why we have selected this for my time series graph, right? So we are done with the this graph as well. Next is another very useful graph called donut chart. The donut chart is very much equivalent of the pie chart, but we have a hole in the center, right? For that, again, we have a data frame available, right? And I'm just sending it to the using pipe operator. I'm sending to the plot.ly, and we are specifying the labels and values. Plus, we are also adding a function called add_pi, in which the hole is 0.6. The value of the hole go to the 0.99, right? 0 to 0.99. It's the range we can define the hole. Let's define the donut chart. It is same as pie chart, but with the have a hole in at the center, right? Let's see the donut chart as well. I'm pressing enter, and here if I can call FIG, I can have the donut chart in front of you. You can see it here. We have a labels available, right? And if I put my cursor over the top, I can see that this vegetable contributes to the 29%. The beverage correspond to the this one 4500 means 52.6%. Dairy 12.3, and the fish correspond to 5.85. So this is the like kind of a pie chart, but we have a hole inside it, right? And we can change this hole range. If I can change the parameter this 0.6 hole, it can go up to the 0.99 at the max value. Next, we have a inbuilt heat map available. Although we have the heat map, means like it will be showing the multiple colors. Darker the color means more is the density, more is the intensity over there. Let's see the heat map, and we have inbuilt data available called volcano in the R. Using that, let's go with that, pressing enter, and you will be having this heat map available, right? Heat map correspond to as I've already told you that it depends upon the intensity of the color, right? More is a brighter color means more is the intensity. This is how we can define it, right? This is called heat map. Moving further, we have our 3D scatter plots available, in which we have everything is same, but we have to just specify the type equal to 3D, right? Let's run it as well. So all this information, guys, actually again, I'm not covering all different type of graphs because it's have a huge library or rich set of library. I'm just taking some examples that what kind of graphs are possible with the plot.ly. So I'm pressing enter, and you'll be having this the 3D plot got generated for you. You can see it here, and this one we can rotate as well. You can see it is rotatable. I'm just rotating it. You can see it's the same for iris, but the only good point is that it's a rotatable. We can rotate that, right? This is called as a 3D scatter plot. Last one is called 3D surface plot. Again, it will be on a three-dimensional space. Again, I'm using volcano as the inbuilt data of R. Let's see it here. The last graph of the plot.ly. Again, this is the 3D surface, and it's again we can rotate that as well. Just see the beauty of that, right? It's magnificent, right? So this is the point. I hope guys you must have understood the plot.ly as a package. It has got a lot of features which you can explore further, right? I'm not covering all different type of graphs. It has got multiple other graphs which you can draw with that. Thanks for watching, guys. See you in next video.